What's going on, YouTube? Today we're building this NLPWM mod in our new ABM-NX enclosure. This one here is powered by a 4S 2200 mAh lithium polymer battery. You can see the NLPWM board in there. The NX enclosure has a 16mm cutout for the fire button and 30mm recessed 510. So stick around and we're going to build this thing. First, we'll address the display here. I've mentioned it in a previous video, the unregulated mod build that has the same dimension cutout for the voltmeter. You see the corners there are slightly rounded. The tool that does the machining is round, so it'll never be a perfect 90°. And because of that, I'm just going to soften the edges, the four edges on the display here. Just a few passes with a file. And I'm going to do a dry fit here. I want to point out a little issue with the display. I've got the board temporarily mounted in the board holder, and I slide the display in. It only goes in one way. There's an extra pin on one of the rows there. And I'll put that in the enclosure. Now the holder holds the board the right distance for the actuators to fit without rattling, but at that distance, you see here the voltmeter sticks out a little bit too far. The display sticks out too far. The easiest way to address that I found, you see those little standoffs on the back of the display. I'm going to file those down a little bit. Now I could have made a board holder that held the board away from the enclosure the right distance for the display, but then the we would have needed to maybe glue some little spacers behind the enclosure or behind the actuators for those to sit snug against the board. But I chose this method. I'll dry fit that in the enclosure again. Now it sits like a ½ mm below the face, which is what we want. Now if you're using the external mount method, which is what I'll end up doing here, I've got the board mounting holes drilled. You could just screw the board in to hold everything into place, as we're going to tack a few of the leads here. But I'm doing it this way without the screws in case you chose the internal method and you can't screw the board in. So I'm just holding it with one hand. Got a little bit of flux on two of the leads. Any two will do. I'm going to fine adjustment the placement of the display. Bit of flux on the iron, and I'll just tack at the intersections. We'll do one more just to lock it into place. Now we'll pull the whole thing out of there and get in a more comfortable position to solder the rest of those pins. We'll apply some flux on all the pins. And then one at a time, we'll load some solder on the iron and just touch that intersection. You want the iron to touch as much as possible the pin and the little circular pad. One side done. Same thing on the other side. Then we'll cut away all the extra pins. That looks good. So we'll do the 510 next. These are the source 510s. They have a retaining clip, a circlip, that hold in the guts. You need a special tool to remove that, but you don't need to disassemble it to solder it. I'm using 14 gauge wire. We're gonna tin everything. I'll strip it much shorter on the negative here. Now to make the soldering easier, if you screw something into the 510, I'm using the 510 install tool here, just to push the pin out. Now we can get our iron much onto it. Get ourselves in a comfortable position. Have something underneath the 510. If we push down on it, it'll be stable. It's the perfect length, enough room there to get the iron both on the wire and the pin. A little bit of flux in the pinhole. Load up the iron. Again, with the tip, I'm touching both the pin and the wire. I'm going to hit that again with some more. Clean it up with some alcohol. It's a nice looking joint. Now for the negative, bit of flux on the negative clip. Load up the iron again. Looks good. Now for our XT60, I'm going to tin the connector. And a little tip here, even though we're only soldering one side of the connector, assemble the connector. This way, if you overheat the pins, there's no chance of it warping out of shape. We'll strip and tin the wires for the XT60. Check my length here. And strip a little bit more. That looks good. Same for the positive. Now, same as the 510, want the iron to touch both the pin, the connector, and the wire. That could use a bit more. And repeat on the negative side. That looks all right. Now I'm going to do a dry fit here. I'll just put the board onto the board holder and screw it into the enclosure just to measure my lengths on all the wires that'll connect to the board. We'll just do 2 of the screws for now. Just a straight short run, I think will work here. Same for the negative. Now for the battery. I'm putting some tape on the positive side of that wire that's flopping around in case they both touch the enclosure while I'm messing around here. Now part of me wants to go straight run like this up to the board. But I'd kind of need to shorten the length of the cables on the battery, which I don't want to do. Whoever ends up with this mod, if they need to replace the battery, I don't want them to have to modify the stock length on there. So I think I'm going to go from the top like this. Just making sure there'll be enough clearance for the 510. Unlike a DNA mod that there's no balanced charger on the board here, so that charge connector doesn't need to be at the bottom. Now we can cut everything to size and tin. Now I didn't realize here, if I solder it onto the board, then I won't be able to get the nut or install it into the enclosure like this. So I'm removing the retaining clip. If you don't have a tool to do it, I would say either don't solder the 510 right away until it's installed, or what's probably easier, don't solder this wire onto the board until the 510 is installed. Well, we get to see how to disassemble a Source 510 and what it looks like inside. We'll tin everything, a little bit of flux. Load up the iron. All right, now that fire button. These LED fire button, so two of those pins control the closing the circuit, the switch, and the other two, there's a positive and negative to power the LED light that's in there. Instead of running 4 wires to the switch, I'm gonna jump the ground onto any one of the switch pins. Well, not the positive, but any one of the 2 pins that operate the switch. And these LED buttons we have, they're 5 volt, so there's a resistor inside, and so the switch expects 5 volts to operate. If you're building a mod with 2 cells, that's close enough to the 5 volts that you could feed it straight battery voltage. You could go off the 510 so that it will only illuminate when you fire. Lucky for us, on the NLPWM, there's a 5 volt out that we're going to use to power the light. So I'm going from the negative, the LED, onto any one of the 2 switch pins. We'll get our connections onto the board made. A little bit of flux on the pad. And touch the pad and the wire. Now for the battery connection. A little bit long here, I'm going to cut that back so that not too much of it sticks out on the other side of the board. Little cleanup with some alcohol. Now the wires for the switch. I'm using 24 gauge wire for the switch. So there's the 2 volts to activate the switch, and on the left there's the 5 volt that'll power the switch. And it only sends the 5 volt when you hit the fire button, so it'll only illuminate when you fire. Looking sharp. I think we're just about ready to put this thing together and go the actuators. I don't have the nut on there yet, but the hole's tight, so I'm able to, I need to screw it in to get it in there. Okay. And I'm putting a little bit of flux. The sticky residue that builds up on the flux applicator is perfect for holding those tiny nuts on the tip of your finger. Looks good. Board's mounted. There's a rubber ring little gasket that come with the external fire buttons. I use them. I recommend using them. As you tighten the nut down, it squeezes it tight onto the enclosure, and you don't need to over torque the nut. Making sure my pins will end up in a position that'll be easier to solder to. Now with my thumb here, I'm pushing down on the button to compress that little gasket. Make it easier to tighten the nut. And you don't need to go too tight here. So that red wire that's coming off of our 5 volts, that'll go onto the positive pin for the LED on the switch. A little bit of flux on the switch too. Now it didn't matter earlier which side of the switch we jumpered the LED ground or negative to, but it's going to matter here which of these two switch wires goes to that side. The switch wire on the, what I'm going to call the left here, or towards the top of the board, is the one that needs to go onto the side of the switch we jumpered, or we bridged onto the negative. So this is the switch wire on the right, or what we see as the bottom side of the board. That goes onto the non-bridged side of the switch. And this one here onto the bridged side of the switch. And the reason it matters, when you close the switch, it's closing the ground circuit, but the one that's going to the bridge side is the side of the ground that's on the output. Now here's where I regretted soldering that 510 wire onto the board first. It's tightened there, and it was kind of difficult to get the little retaining clip, get that tool inserted in the two little holes on the retaining clip to get it back in there. So if I do this again, I would solder the board last instead of the 510 first. Or just install the 510 and then solder the positive pin into the 510 while it's in the mod there. I'm going to make sure that clip is properly seated. I'm going to push the pin back and forth, make sure it doesn't pop out of there. That looks all right. We'll tighten down the 510 using the 510 install tool. There's enough room in there that I'm going to use a wrench on the nut inside. Another nice thing about the big 30mm 510 here, if you slip with the vice grips here, there's less chance of it hitting or damaging the finish around the top of the mod. Then to release, just torque it either way, and once the pressure releases, you can unscrew it out of there. That all looks nice. Clean routing of the wires. Want to get the negative lead below the 510 here. There's plenty of room on the top to tuck that away. It's a nice fit. Now the fire button isn't lighting up here, and that had me confused for a while. I reread the documentation for it, and you need to enable the 5-volt output in the settings for the LED. We'll get our magnets installed. My little trick, put your whole stack of magnets together, mark the opposite ends with a Sharpie, and then feed from the unmarked side. Here too, feed from the unmarked side of the stack. I'm using CA glue here. I used to use epoxy, but it was more trouble than it's worth. The CA glue is easy, dries much faster. We'll let that dry. I went and fixed that setting for the fire button. See it light up here. I also added I epoxied a piece of Velcro on the bottom of the enclosure to wrap around the battery and hold it in place. It's pretty snug. It probably wouldn't have budged anyways, but We'll get a tank on here. Now my usual dinky mouth-to-lung Addy would look tiny on a mod this size, but luckily last batch of NLPWMs I purchased from Mark at Voltrove, I asked if he had some larger tanks to lend me for this, just for the build video, to have a nice big atomizer on the big enclosure. So this one here is the 30mm Voltrove. It's a nice looking tank. Black anodized mod, black tank. And if that's not big enough for you, here's the 41mm. Now the enclosure is 40mm wide, so there's a 0.5mm hanging off on each side, but I'm calling that no overhang. That looks really great, the proportions. So big thanks to Mark for lending me those for the build video. And there we have it. So recap, it's the NLPWM board in the ABM-NX enclosure. We got a 2200mAh Lipo in there. 16mm LED fire button. 30mm recessed 510. Sharp looking mod. So once again, guys, thanks for sticking around, and we'll catch you next time.